Let us derive the formula for tangent of A over 2, tangent of B over 2 with tangent of C over 2. For this, we are going to consider the half-angle formula of sine as well as cosine. Before beginning, let's consider a triangle ABC. We're going to consider BC, CA and the side AB of the triangle and represent it by the letter A, B and C in lowercase. Or in other words, we are going to say that A, B and C are going to be the sides opposite to angle A, B and C respectively. Now, the reason why we're expressing the sides of this triangle here, A plus B plus C is going to give us the perimeter of the triangle ABC. If we take the half of this perimeter, this is going to be represented by S. S here is going to be the semi-perimeter of the triangle. This is the semi-perimeter. Now that we have the semi-perimeter, we can express the sine of angle A over 2. So sine of angle A over 2, that's given by, we've already derived this. We take the square root. Underneath the square root, we have the product of S minus B times S minus C divided by B times C. For sine of angle B over 2, that's going to be given by the square root of the product of S minus C times S minus A whole divided by C times A. And sine of angle C over 2, that's going to be given by the square root of S minus A times S minus B whole divided by AB. Fine. Then we also have the expression for cosine of angle A over 2. So cosine of angle A over 2, that's given by the square root of S times S minus A divided by BC. Then we have cosine of angle B over 2. This is given by the square root of the product of S times S minus B whole divided by AC. And cosine of angle C over 2, so that's given by the square root of S times S minus C whole divided by AB. Our goal is to define tangent of A over 2. So tangent of A over 2, now we can easily define this. So this is going to be simply the ratio of sine of A over 2 to that of cosine of A over 2. So that means we will use sine of A over 2. So that's going to be the square root of the product of S minus B times S minus C whole divided by BC. This is going to be divided by cosine of A over 2. So that's given by square root of S times S minus A whole divided by BC. So if we combine them, this is going to give us the expression, the square root of S minus B multiplied to S minus C divided by S times S minus A. So this is the formula for tangent of A over 2. Similarly, we can find out the tangent of angle B over 2. So tangent of angle B over 2, that's going to be given by the square root of S minus. So here, how to remember this? So here we have angle B. Now the sides that the adjacent to angle B are going to be A and C. So here we'll take S minus A multiplied to S minus C divided by, now we have already used S minus A and S minus C. So in the denominator, we'll be using S minus B and multiply it with S. And then we have tangent of C over 2. That's going to be given by, we'll take the square root. Underneath the square root, we have S minus A multiplied to S minus B, where A and B are the sides adjacent to angle C, divided by S times S minus C. If we have tangent, then we can also define cotangent. So cotangent of A over 2, that's simply the reciprocal of the tangent function. So that means we have the square root of S multiplied to S minus A whole divided by S minus B times S minus C. Similarly, we can define for cotangent of B over 2. The cotangent of B over 2, that's going to be square root of S times S minus B divided by S minus A times S minus C. And then we have cotangent of C over 2. Cotangent of C over 2, that is going to be given by, to take the square root. Underneath the square root, we have the product of S times S minus C in the numerator, and this is going to be divided by S minus A times S minus B.